All right. We'll go ahead and get started here in just a minute or two more. Hope everyone's doing good. All right. We will get started in just a minute or two more here. Feel free to take your time, grab that cup of coffee or glass of water. Come on in, settle down, and we will get started about energy code paths. All right. Let's see here. Looks like the chat is working. Perfect. Okay, cool. All right, well, we're about a minute past, so we'll go ahead and jump into the fun stuff here today. First of all, I am not Josh Hartman, so I do apologize for that. He's a wonderful presenter and a great colleague here. He had a chapter meeting he had to attend today, unfortunately, and so he asked that the team jump in and help kind of pitch hit a little bit here. So with that, I am jumping in to help out. I've done a few of these for Texas before. My name's Andre Hayen. Typically, I handle a lot of stuff with the Colorado program here, but Hope and Josh and I all work together on these same sort of programs. And hopefully, I will be a decent substitute today as we go through our energy code compliance pathways. So to go ahead and kick things off here, do want to remind everybody that we have a great new resource that's up and functioning for a website for you now. So that's your Texas Energy Codes and Standards Program website. It can be found at texas.my, I think it's tx.my.xlenergy.com. So right there at the bottom there, if I could more easily, it's funny, words are easy, but letters always trip me up when I try and start to read them off out loud. But easy way to be able to get over there and take a look as to what we have posted, all the wonderful documents, webinars like this, and other resources we try to make sure are kept up to date. So please take advantage of that resource whenever you get the opportunity to. There is a number of great stuff up there. We put out regular newsletters going over, first of all, things that we're hearing from you that we might hear, hey, this has been an issue, this has been a concern. I'd love an article about, say, whole house mechanical ventilation or about our energy code pathways or how are we handling heat pumps? What should we be looking for in these? These are the kind of things that we love to make sure are up and adequate for you and are usable resources that you can either use for trainings or put out to the public. So please take advantage of those. And then obviously previous webinars, if you want to take a look and see what's out there, this is a great space to be able to do so. So Josh and I are alike on the fact that we love to start with the why and understand the how. I am very much, if I do those personality inventories, I show up as one of those like big picture kind of people. And this really like vibes with me. This is a really good way to, I think, have this conversation. Because if we understand the intent of the energy code, which can sometimes be a bit tricky at times, and it feels like it's not always intended to be helpful or to be our friend, oftentimes it's because we're misaligning the technical requirements with the intent of that document. And so let's start there, start talking about why. Well, built into the building code's DNA is the requirements to make codes minimums, minimum standards, minimum requirements, right? And that's inclusive of a number of things, right? We talk about means of egress, we talk about structural strength, health, safety, health, and welfare. And included in that long list is also energy conservation, and then other parts that are adjacent to energy conservation, like sanitation, light, and ventilation, for providing reasonable means of safety while at the same time providing these goals. And so the IBC, the IRC are meant to support this from the ground up, and the Energy Code helps us identify the places where we can use approaches in the Energy Code, the pathways in the Energy Code, the technical requirements of the Energy Code to support those long-term goals. And you'll notice that there are two words here that I really like and I really like to harp on, which are flexibility and innovation or innovative approaches. And those are crucial to understanding this space because the energy code space has changed so much over the last 30, 40 years. Probably one of the places that we've really seen the biggest acceleration in terms of building products, products coming to market, changes in consumer expectations. And this is the place where things have really, really become a driving force for what the future of the built environment might look like here. But it's important to also remember codes are minimum standards, right? That's where we're starting from. So how do we ensure that we can meet our minimum standards with the approaches allowed in this document and imply that we can also be flexible in those places and we can be innovative in those places? How do we make sure that there are new products that can be used? There are new techniques that are able to be integrated into the code. And that honestly does start with the compliance pathway selection process and identifying what's necessary on those plans, because that's going to decide how limited of a box we're going to play in versus how expanded, how much we can do as far as creativity. This is a place where that's really going to align in a very deep sense. So first things first, we got to talk about the scoping provisions of the IRC and the IBC and how they relate to the energy code. Now, typically speaking, if I was looking at that apartment building on the left-hand side, right, I'd be picking up the IBC and I would be carrying that with me for every inspection that I gave, right? Meanwhile, if I was going over to that residential home on the right, well, that would typically be the IRC. That's the book that I would take with me to walk through that building. But the IECC is significantly different in that because it does apply residential provisions to residential occupancies 3 stories in grade plane or less, right? So once you break 4 stories, that's the way I should say that, really, 4 stories or less. Once you break 4 stories, then you're into that place where we are getting into the commercial requirements of that code and needing to treat that differently. So that is one of those places that we want to be really clear about the applicability to those buildings. So I'm sorry, 3 stories in height. I did say it right the first time. I don't know why I always mess that up when I try and say if it's 4 stories. But R2, R3, and R4 buildings that are 3 stories in height or less above grade plane are going to be residential building provisions. And that's R2. That's your apartment buildings, right? There's a number of different residential type buildings that we are going to apply residential provisions of the IECC to, despite we otherwise would build this as a commercial building. And making sure that that scope is differentiated and that we're applying the right provisions to the right type of build is really important. It's also important to recognize that there are instances where we might look at that slightly differently, where we have things like podium construction, for instance, or a soft story or things like that, right? Now, if we have a podium construction, this is still now 4 stories above grade plan. That crosses that 3 story or less threshold, right? But what if I had 2 stories of residential and a story of commercial below? Well, then the residential provisions of the code could still apply to those residential apartments, and the commercial provisions could apply to that commercial occupancy. So it's really important to parse that out from get-go and make sure that designers feel comfortable having that conversation. Staff's very clear about that from plan review on to CO, that we're recognizing that these things can be applied differently. And so our group R2, group R3, and group R4 are all residential construction groups out of the IBC, but we would apply those residential provisions to them as the solution to be able to build them. So here's some more great examples of that applicability question, right? So we look at right here, it looks like we have a sales office. Actually, you know what that is? That's a bank, Tangerine, forward banking. And that's made out of shipping containers. I was really convinced at first when I looked at that that was a sales office, like a little pop-up store or something like that. But no, this is a bank. That's a very interesting use to repurpose that, right? That's going to obviously be commercial. And right here we have definitely commercial tenant finish spaces. Looks like these are empty and vacant at the moment. We're going to apply those commercially. We also have this building right here where it's a residential apartment building. This is an R2, but it is above that soft story here that's also included. That makes it a 4 story building, right? And this 4 story building is going to meet those provisions of the code accordingly. Meanwhile, if we jump over here, we can see commercial and then multiple stories of apartments as well. So that's kind of the breakdown of how we're going to look at that applicability question and why it's super important to have that first step parsed out is, are we applying the right book and the right sections of the book to the project in question? So now we're going to look at what we basically designed the IECC to address. And there's really four basic primary components that we're going to talk about: the thermal envelope, the air barrier, mechanical systems, and power and lighting. That's going to be our main breakdown for these when we talk about the four major components. Let me move something here on my screen just so I have an easier time, because I keep trying to change this over and it's not liking it very much. There we go. Maybe. There we go. So when we go about trying to apply this properly, what are the things that we should expect to see when we talk about applying the IECC in Texas, right? Well, the first thing that we should look at seeing are our construction details, and that should also include an energy compliance path. So 103.2 is very, very clear to you. It tells you flat out of the gate, hey, if you want to build something, you're going to owe us some explanation on the construction materials that tells us, hey, we are going to apply this particular code, and we're going to use this particular path in order to be able to do it. There we go. Sorry, this thing's still fighting me a little bit. New computer update. It's been fun to get used to Windows 11 here. So that being said, right, when we look at this and we look at sort of the signposts in the code to say what pathways are we allowed to take, well, we have three basic options here. We have prescriptive, we have total building performance, and we have energy rating index. We're going to break each of those down today at a very high level, just to go over what are the similarities, what are the differences, and why it matters, right? And so our application for these should be for new buildings. And then when we talk about additions, alterations, repairs, remodels, we're going to take you over to chapter 5 to make sure that we are applying those appropriately. But when we go ahead and do this, when we talk about prescriptive, we're going to be talking about sections R 401 through 404. We're going to be talking about, if we're doing total building performance, we're going to go to R 405. And then with the 21, if you want to go over to energy rating index, you're going to go to R 406. So let's start breaking these down as what they really mean out of the code, and let's take a look at the actual sections that support them, right? So right here with prescriptive compliance, we're given that 402 through 406 and 408 definition of what we're going to be looking at here. We also talk about dwelling units being identified if they have mechanical systems that serve multiple units or if they are independent units, right? Otherwise, we're going to try and apply the residential mechanical sections associated with that. That's what R406 is going to point you over to here. And then total building performance, we're going to jump over to C407, right? And when we jump over in that commercial, the difference here in commercials, we don't have that ERI method. That is the big difference on commercial, right? We only have ASHRAE 90.1. And the thing that you want to know out of the gate here is ASHRAE 90.1 is like its own standalone off-ramp onto another highway, right? You can take that road, but you have to take that road without jumping back to the road you were on. That means that the mechanical, the electrical, the water, power, water surface heating, power distribution components, everything in 90.1, you will do out of 90.1 if you use 90.1. You can't take bits and pieces of 90.1 and switch back over. Once you're on that highway, you are headed that direction. So that's the real thing that I want to parse out when we talk about that difference between residential and commercial. So when we jump over here, right, if I jump over to this residential home and we start looking at our code analysis, first thing I want to ask, and first thing I want to know is, what is that compliance method that we're going to take, right? Do we have the identified compliance pathway? Do we have the information that we need? And this is a really important place that I harp on, because you can be specific about this. There's more than one way to go about, say, for instance, the prescriptive compliance method from a thermal envelope perspective. We're going to get into that a little further. But there is a U factor method, there is an R value method, both of which do have some specific requirements. The U factor method is typically the most restrictive, I should say, method. The R factor method basically is giving a assumed value of an assembly based on a lot of good construction knowledge, a lot of basic assumptions being made about building a certain way, and so they're able to say, okay, yeah, if you put this R value in that wall, this is how it's going to perform. This is typical framing. We know how that's all going to work out. U-factor method's a lot more specific. And then let's say you wanted to trade things off. Well, there are ways to do that even prescriptively, but that's also going to require some additional reporting. So as a plans examiner, one of the first things I want to know out of the gate is what pathway are you going to take? And the more specific you are with that answer, the easier it is for me to guarantee that you're going to get the information back that's correct when it comes to your plan review. Because I'm going to be able to go through that and say, oh, okay, if you want to say do some trade-offs, then you probably owe me a separate report, like a res check or a com check. And knowing that right out of the gate, I know whether or not I even have a complete submittal. So from a front end perspective, this can really streamline how much time your plans are spent waiting for additional documents, waiting for deferreds, and can ensure that we're setting good expectations all the way through the process as a whole. So when we talk about the prescriptive compliance, we already talked about, for the residential sections, right? We're looking at R402, R403, R404, which is going to be our envelope, our systems, and our lighting, right? So R402 is going to be the thermal envelope, and the thermal envelope is really our insulation values and our air barrier. Those you could kind of see as one, or those are included in that 402 discussion. 403 is going to be our mechanical systems. It's going to be water heaters. It's going to be our efficiencies for that sort of thing. And you're going to see a similar sort of structure when it comes over to the commercial code. And then you're also going to have lighting in this particular section of 404. And that's going to help figure out, okay, what is the lighting distribution that we're going to use? What's the efficacy of the lights that we're going to use? Are there any requirements for the exterior of the building, which there are in the 21? And that's going to help you break that area down as well. So let's start with our insulating materials here. And let's get into what's on the actual set of plans here. And I'm going to ask you, what do you think? Do you think this is enough information if you're looking at that? And I hope that's big enough on your screen, but I'll read it for you here. This first blue arrow that we're going to highlight. The first thing it says is roofing insulation per code requirements and specs. So, would you pass that? Would you look at that and say, yeah, that's adequate. That's enough information for me to say that you've done your diligence and I have a full review? My first thought is probably not, right? I don't know what type of insulation. I don't know if that it's drawn in here. I've got my little insulation squiggly that's on the ceiling here. So I'm assuming that we're maybe blowing in or we're putting in bats over the ceiling. But I don't know. I don't know the depth of that bat. I'm not sure what that bat is. And of course, we have different climate zones in Texas, right? We also have places on multiple codes in Texas. So if you're on the 15 or the 18, you might be looking at, say, your wood framed wall value right here, right? And so here again, I've got a set of plans that offer a lot of choices. I've got a 2x4 or 2x6 stud per floor plan with 16 on center bat insulation with vapor barrier per codes and specs. Oh boy, the problems here are, okay, what type of insulation are we going to use? So we have bat, but are we just filling the cavity? Are we overstuffing the cavity? Is that going to be enough insulation? So we would say that should be an R20 if we jump over here to our tables, right? R20 over here. Now, if I jump up to our 2021, that could be an R30, right? So right there, we have a mismatch between our framing. If I'm on the 21 code reviewing this plan, and they're proposing a 2x4 or a 2x6 wall, I'm gonna have a really hard time getting enough insulation out of a 2x4 wall unless I add something like maybe 10 continuous insulation on the exterior. Otherwise, that's going to be pretty tricky for us to be able to meet that requirement. So right here, we don't have the information necessary to be able to say, hey, you've got something that we need. So right here, this would be a comment that would probably be written, right? Sheet 7, right? 7 of 7, here we go. Provide the specified insulation R value or assembly U factor for the wood frame wall to demonstrate compliance with the IECC, right? And you're going to point them in the direction of the table that they should be using for their insulation values. But that is the kind of level of of detail that we do want to be asking for a number of reasons. It's helping size in that conversation alone, right? We went from having basic information that only gave us a little bit of information. Basic information, they only gave us a little bit of information. We went through basic information on the insulation that informed whether or not the framing system was adequate for it, if we needed anything in addition to like exterior insulation. And if we're doing that, then we really have to question, okay, it says that we're going to put in a vapor barrier. Well, our vapor retarder requirements out of chapter 7 of the code, right? If you go to your IRC and you crack open chapter 7, you're going to look at that and you're going to say, well, there's a lot of different types, right? There's a class 1, class 2, class 3. And so which one are we using? Because if we're just doing the bad insulation, we might be able to use a class 2, we might be able to use a class 3. Well, I don't know if it's necessarily the most prudent choice, but it might be a choice that you could make. But then if we need to add additional exterior insulation, that impermeable insulation may complicate our ability to provide that vapor barrier system. So just by not adding enough information about the insulation itself, we now have multiple questions about that entire wall system as a whole. The other thing that I'd really point out here and like spend a little time to really think about for a moment is that the same section in 103.2 that tells you you have to get these R values, and I think we'd all agree looking at this, the R values are so important that you really can't tell whether or not you have the information you need without them, right? The R values are that important, and that same section that tells you have to get R values and fenestration and a number of other things, air sealing details, all that good stuff, also tells you have to have that energy compliance pathway identified. That's how important it is. It's just as important as getting the R value on plans. So what about here? We have optional R3 foundation insulation. And that's going to be a little tricky because in the 21, for instance, slab edge insulation, if that were the case, right? In this case, we're looking at a basement. But if this is the only detail that I have identifying anything about perimeter insulation, well, that's non-negotiable. And that's one of those places that could be easily misidentified. So it's one of those places again where it's worth taking the time to say like, hey, are we being very clear about all of your requirements for your insulation and all the types of construction that you're going to have out there? If your garage, say this house has a basement on one side, garage on the other, and this is the only cut view that we get, this is the kind of thing that maybe leads to that being missed somewhere out in the field, for instance. It's one of those things that could create an issue. So again, we point to sheet 7 and we say, hey, we should probably identify exactly how we're going to deal with this. And do we have the insulation necessary for a below grade wall if this is the only insulation being provided? So again, if we have this sort of issue where we are looking at the overall picture of this particular building and getting that code compliance path identified, this might be a place where now we're looking at, okay, we've got multiple things that don't quite match, and we've got multiple types of construction in terms of the wall assemblies, right? We've got 2x4, we've got 2x6, we've got a roof that's not very clear, we've got a foundation system that's not very clear either. Are they trying to trade off? And they could be, right? There could be legitimacy to that. I don't know that those values would necessarily get us there, but that might have been the intention. And so with that, that means I should be getting a report back, right? I should be getting a compliance certificate, like a com check or a res check in a residential case. Tell me identify what we're going to be trading off and to make sure that those values from those assemblies are going to match the values from the plans themselves. So here's where we'd start to break that down, right? We'd take our two documents here and we'd look at our fenestration details, right? We'd make sure that we have the right amount of windows on the right sides of the house in terms of elevation and exposure. We know that to be a significant load change, right? When we look about doing our manual J's, and we know that placement of those windows, size of those windows, and the U factor of those windows are super important. We obviously have code restrictions as baselines where we say, hey, you can't do worse than this typically. But in addition to that, if we're going to play around with some insulation values in some places, then yeah, that's going to definitely factor in for our ability to say, do we have the information that we need? So let's start breaking it down as we were to go through this, right? So this is looking at, remember, our prescriptive path really has three separate ways it can go. It can go with your U factor method, which is its most simple, by the book. You're going to total everything up right out of the ASHRAE Book of Fundamentals. I'll also tell you, almost no one uses this from a residential perspective. Almost no one typically does, but it can be. It can be used under the right circumstances. It has value and merit. The reason that it's really important, though, is to understand when you go through the rest of these, right? So I told you there are three. The other ones are R value, which we're super familiar with. A lot of folks have used that pretty much standard practice as prescriptive for a very long time. Third one we have, right, is our total UA alternative, right? And this is our trade-off ability in residential to say, hey, I want to use a COM check to not necessarily build the assemblies exactly as they'd have to be. I want a little bit of flexibility with that, but I'd also don't want to do full energy modeling. Great. Okay. Well, this is your method to do it. Comes with some guardrails where it says, okay, you can do X, but not Y. Well, like I said, some backstops and things like that. When I talked about the U factor method being so specific where you add everything up, the ComCheck is doing the U factor method for you. It's just doing it twice. So what it's doing is it's saying, okay, we're going to take a house that is built, proposed out of the code with the U factors that the code requires prescriptively. We're going to take that and we're going to compare it to a proposed design based on new U factors that are proposed in these assemblies. And that's where that comparison is happening. So that's what this thing is doing when it says, okay, if this beats or passes the UA trade-off and it's 11% better than code, it's 11% less thermal conductance, 11% better in terms of a U factor comparison between that design building right out of the IRC for your U factor requirements versus this proposed piece of construction, right? And this is how we're doing that. We're breaking these down into our relevant parts here, and we're putting in, say, cavity R values so we can clearly estimate, okay, hey, we've got a flat ceiling over here. This should be an R38, right? Okay, that's what we're using in order to determine this. This could be, the 21 code has a variety of different, ceiling height insulation requirements there. It can go up to a 60, like in my jurisdictions, right? And that's substantially more. That's going to inform whether or not I look back on the building plans and go, if you're telling me you're getting R60 in the ceiling, do you have the depth to do it, right? Do you have the right framing members? So again, we're able to use energy as a means to inform a better overall plan review as we think about that down the line and make sure that we're not making mistakes. But this is what it's also doing for those proposed U factor versus those required U factors. So this is taking those gross areas, right? So we're taking this perimeter square footage, for instance, or excuse me, in this case, this is gross area because it's the ceiling. So we're looking at that ceiling, right? Taking that ceiling and we're saying, okay, well, the U factor it's supposed to get no matter what is 0.024. We're going to beat that a little bit by 0.23. So just a hair. A lot of these are also aligned pretty much to be the same, but then here, right? Remember, U factor is one of those things that it's like golf, right? The lower the score, the better it is. It means the less thermal conductance is occurring. And so if we look at this with the golf score thing, right, we compare this guy right here for our doors. Well, here's the required U factor. This is more, right? This means that this is less efficient, but then I look at this next window, this is less. So we can see where that trade-off is occurring compared to that required U factor. So we'll look a little further on our exterior glazing, and then we're going to go and compare that to the window schedule that should be in our plans. Because remember, we have that requirement in 103.2 that says you need to give us your U factors, you need to give us your R values, you need to give us your area weighteds, you need to give us all of those components out of 103.2 to say that I have the information that I need, and so I can compare it against this. If someone just tries to say, hey, well, here's my COM check, it's got all the U factors to it. Again, it's not on the plans. This is a really important component of making sure that you're getting that full assembly compliance when you look at this from the outset, and talking about the way that the compliance pathway is going to inform this conversation of what even should be on your plans and how it should be submitted and turned in. So right here for our U factors for climate zone 4, for instance, We have our vertical fenestration, right? That's our windows at 0.30, solar heat gain coefficient of 0.40. Remember, U factor is how much heat's going to penetrate that window. Solar heat gain coefficient is the solar heat radiation that is going to actually pass through that window. So this is its ability to fight thermal conductance. This is the heat and cold thing, right? All molecules in the entire universe that are excited and warm want to move to places where it is cool, right? It's that old adage where people say like, well, heat convects, right? Well, no, heat does a lot of things. It radiates, it convects, it uses any tool at its disposal to normalize. So hot wants to move to cold. That's what basic physics says throughout all of the universe, and our houses and our buildings are subject to the same forces as the ones out in the stars, right? And so this is exactly what that's telling you is, hey, the thermal conductance of this particular assembly is 0.30. This is how much radiation, solar heat radiation, as the solar rays penetrate through that window, how much of that is actually being let through. So we can continue to keep looking at this, right, and breaking down this report and going over what is in our actual U factor there. And we're going to compare that to wherever we're going to find our information on our plan. Say, for instance, we might get this right here as general notes saying, hey, we're going to get tempered glass in the right places. We're going to field verify jamb thicknesses. And then if glazing is not north facing, it is to be 1 inch clear solar band 70, 1/2 argon, clear tempered. And it gives you a little bit more information there. But what we're still not getting is what that U factor is supposed to be, right? It's identifying definitely a make and model of window, but we don't know about that performance aligning with the requirements of the report we've been given. And that's especially imperative when we talk about trade-offs, because it could be that you're special ordering something that's not typically brought in to your local Home Depot in that area, or, the kind of window that is significantly more energy efficient. And so, this can't just be replaced by anything if it got broken transit. This is the kind of stuff that we want to make sure are really well identified through our plan sets. So again, we might break this down and say, hey, we need you to specify the U factor on this. We need the solar heat gain coefficient, and we need that for all of our fenestration details to comply with this particular section of the code. So then how does that inform the real life, right? So we've done this on paper. What's it going to be in real life? Well, now your inspector, right, should be able to go and visit the site and see the plans and see this identified. Great, we've got a schedule. And now we're going to compare it to our window sticker. Oh, sorry about that. We're going to compare that over to our window sticker out here and see that this actually matches for our values that were required of us. This is also one of those things of setting good expectations. I've had, like, I think 3 homeowners in my career that have been building their own homes or doing their own remodels, and they were so excited to set windows, and then, they've got a plywood floor in there. They haven't done anything, but they're so excited. They bring in like a lawn chair and they just want to have a cup of coffee looking out what's going to be their new kitchen window or new dining room window or something like that. And they peel all the stickers off because they want that clear view of the mountains. And then I show up and I go, oh my God, where did you put them? Like, please, please tell me you saved them or you took pictures or something. Help me help you in this, because no one wants me to use the basic, the window U factors out of the code that you have to if the windows are not identified for their performance rating. So it is one of those things you want to be very clear about. So like I said, we've got 3 options here. We've talked about prescriptive and how prescriptive breaks down and sort of has three separate kind of sub pathways there. And we're going to continue to break down the remainder of its section. But to remind you, then we're going to be looking at these other 2 here as well. So let's talk about our performance, right? So when we talk about our energy performance here, and we talk about, nope, there we go. When we talk about using modeling software and energy performance, one of the things that I really want to like identify, or at least something that works well for me, is trying to think in terms of the way that people understand their sort of energy budget or the energy, costs, and how this informs things like ERI, or how this informs total building performance and that sort of thing, right? So if we go into our modeling softwares and we start using those as methods to try and drive compliance, what's that going to mean? Well, total building performance is based on cost out of the 2021 IECC. And so what that means is, hey, if I have a house that costs X amount to heat, and that's what you can see here on the left-hand side, right? And then I can beat that through my design to make it more efficient, then there we go. That's going to be a fair comparison, like for like on that. To say that, hey, this house is more efficient than the average house designed out of the IECC, and therefore we're going to be able to use this design. So that's what it's doing. So effectively, that would be a bit like taking your car and saying that, hey, gas in my neck of the woods costs $3.50 a gallon. I have to drive to work 4 days a week, and I have to go pick up my kids from daycare and yada, yada, yada. These are all of my like budgeted expenditures for driving and time, right? So as I go through and do that, and I continue to, take the numbers up, I can basically get an idea of how energy efficient my car is based on how much it costs for me to run it at the pump. And to do that on a regular and consistent basis, right? So then if I see that number go up, I know, oh, okay, something's wrong with my car because it's being less energy efficient, right? If my cost per month for gasoline goes from $400 to $500, I know that I have a problem. And it's also a way that I could shop for another car, right? Because I could do that estimation to say, well, that cost for me to be able to drive this could be lower. Or if I added this particular component, like if I redid the exhaust system or the air intake system, did some things to make it more efficient, then perhaps it will also run more efficiently and reduce that cost. But there's folks that look at that, and so the conversation, like in Colorado, for instance, and there is an allowance to be able to do this in the 21 and in the 24, you can look at down the road, where they move to energy use intensity. And that's basically instead of looking at the cost of running that car, we're going to look at the gallons per mile. Because let's say I'm going to take that car on a road trip where the price of gas is volatile, right? If I go from, say, Texas or Colorado, where average cost per gallon is $3.50, and I drive up somewhere crazy like California or Washington State, where it's 6, 7, $8 a gallon, then if I am just interested in the efficiency of my car, but not necessarily the price changes, because those don't reflect what the car is doing, then I might look at gallons per mile instead, because that's a better way for me to be able to tell how efficient that car is, regardless of how much the energy costs. And so if you have areas where there's fluctuations in that for gas prices or electric prices or things like that, or if you have, say, gas and then you deliver propane, right? And the cost of propane changes and it fluctuates a bit, right? Or fuel oil. There's a lot of different ways to heat buildings in the United States. That's part of the reason that there's that ongoing conversation about which method you use and why you use it. And so in our particular case, what this is demonstrating is an improvement of 0.5% in compliance based on the anticipated expenditure for the costs to heat, costs to heat this building. And so here we see it identified in the code in 405.3, where it just needs to be less than or equal to the annual energy cost of the standard reference design. Remember, standard reference design is just that designed house that we built right out of the U factors of the code. If we can demonstrate that it's as good or better than that, we'll be set. So when we talk about our performance-based compliance, one of the most important things that we need to know is, first of all, our proposed design needs to be equal to the requirements here. Now, we've jumped over here, I should say. Let me go back one here. So oh, I'm sorry. I think a slide that we wanted to have in here didn't make it. But as we jump over to the energy rating index method, that's kind of the transition that was lost there. I'm not sure why that didn't make it. But as we jump over to the energy rating index method, we notice right here we're designing homes out of the 2009 Energy Conservation Code. And some people look at that and go, wait a minute here. On one, I have to build a proposed design right out of the house right now and just show that I'm better than it. But in this one, I'm going back to the 2009. Why am I going back to the 2009? Well, so this was identified, or this aligns with sort of, if you know the precursor to what ERI is, sort of the HERS rating method as well. And what they did is they took that as a baseline. And a lot of you have maybe seen that sort of thermometer looking iconography, where you get your reports back for your energy rater and it shows, hey, this house is 54% better, or 36% better. Well, those numbers are individual percentage points better than that 2009 house. And so as the code continues to progress, you'll find that those numbers continue to diminish over time. And so the 15, the 18 really just identified that number. In the 21, you get to a place where you're looking at whether or not there is on-site power production or on-site renewables as part of that conversation, and how those offsets can also contribute to lowering that number down to an approved number. So depending on your climate zone, depending on a couple of things, you'll see that number range anywhere from in the 50s, like 54, 56, 58, to with that on-site power production, you'll see it drop all the way down to the 40s. And so that's what that's expressing, is this is so many percentage points better than the 2009 Energy Code. So in each of these, as you jump over to your different sections here, as you move from the 18 and the 15 up to the 21, one of the other things that occurs is you see some different designs in the code where our compliance paths were sort of interspersed with mandatory requirements, and it was much more sort of like trade-based, so to speak, right? You go to the mandatory requirements first, or you'd see a series of mandatory requirements associated with your lighting or your mechanical systems or your thermal envelope, and then you'd see individual areas identified for prescriptive or for ERI, right? Things like that. And now it's much more grouped based on the method that you're using. And so when you jump over here, you'll see, say, 405.2, you're going to see a nice table that walks you through, hey, you can use this method, but you still have to meet these requirements for, say, your total building performance. You're going to have to look at each of these in turn and make sure that you're still meeting these requirements. And that's great both for a design professional that's setting up that building and going, okay, I want to use my modeling software to be able to compensate for this. It's also great for a plans examiner because now you know this is your checklist, right? You take this guy, you take each of those sections, and you say, okay, in addition to the requirements of 405.2, I am going to make sure that we're meeting all of the requirements associated with everything in this chart. This one on the right here shows what I was talking about before, with the mandatory requirements being interspersed as you work through the book in previous generations. So here you see it in kind of blown up for you for 405.2, where we're saying, hey, you still have to meet the requirements for your vapor retarder, right? Which makes a lot of sense. That actually applies from Chapter 7 of your IRC. And so it still needs to remain aligned, even if you're modeling this house, because we don't want to create wet walls because we're trying to super insulate and we're not thinking about where to tell that moisture where to go, right? And we're not working with the air barrier system with that tangentially. Same thing with eave baffles, right? Eave baffles, again, attic ventilation comes from Chapter 8 of your IRC, right? That's your ceiling construction. That's 806.3, if I'm not mistaken. So that's telling you, hey, you still have to align with that. You don't get to ignore these requirements. And then there's a number of other things that are still even more germane to the energy code about things like your ducts and making sure that they're properly insulated, they're properly sealed, right? Your basic equipment efficiencies, your mechanical ventilation. Again, that's something else that comes from the IRC and the IMC and then realigns with the IECC to tie them all together. So you just see some very different methods of being able to provide that same sort of information. So as we jump over to solar efficiencies here, that is also one of the items. Um, excuse me, solar heat gain coefficient, solar heat gain efficiencies, is one of the other items that has to be maintained in this requirement as we jump back to the 2009. So we're going to make sure that, hey, when we do this proposed design, we're looking at something as good or better. And so here we see the actual energy cost being less than or equal to the cost of the reference standard. So that's where that 2009 comes in on the total building performance requirements section, is that it serves as our backstop for the bare minimums of what we're going to give for a house, even if we're going to trade some things off. We can't reduce beyond certain requirements. And those sit as sort of your method for identifying that, your backstop. And here we see this blown up. Let's say that we're reviewing to the 18 here. Well, here you have it. Here is our proposed energy, right? Basically what this would have been if we just built it right out of the 2018 IECC. And then here is your as designed. And then your compliance tools do need to be submitted with the application for the permit. So basically we need that front end report basically saying, hey, this is how we intend to do this. This is a proposal. And then we get a second report at the end of the job, basically at the finish of the whole thing. I do need to demonstrate compliance that, hey, we met or exceeded the criteria that we came up with when we designed this whole thing, when we came up with this idea. So your compliance permit for your report, excuse me, for your permit application needs to be able to identify where that house is. It needs to be able to identify the individual and the information that's generating that report, and especially the compliance software tool. We need to know that it is an approved tool for the ability to use for this calculation, and then the information that it's getting, we're getting from reputable sources, right? If we're coming up with U factors, we're getting them from the ASHRAE Book of Fundamentals. If we're using costs for energy, that they're legitimate costs, right? They're not just pulled out of a hat to say, well, if I play with these numbers, they'll make it work, but rather, no, this is really the going rate for, gas, electricity, things like that in those areas. Your compliance certificate for your yeah, compliance report for your certificate of occupancy again needs to identify, put your name, your address, all that good stuff on your work. Needs to say who performed the analysis, so that way we know if we have to come back and say, hey, something doesn't jive here, we know who that was. Needs to tell us the real R values and components of what was actually installed. If you did renewable sites, on-site energy systems, then it also needs to tell us the type, production size of that system, so we can demonstrate that the overall conformance is there. So this might be a little bit of what we're looking at when we take that information, right? We get that documentation back. We're demonstrating the initial cost, of the design. We're demonstrating how we came up with those U factors, that we got them right out of the code, versus our proposed, and how we're going to be able to beat that and what we're going to be improving on. A lot of these also publish energy code inspection checklists, so they're giving you some of the information right out of your design that says, hey, these are the things that you're going to have to be looking for in order to make sure that we're meeting our design criteria here. And we do have some really good technical documents available on that website I showed you earlier, where you can go and visit this for yourself and break down an ecotrope report, for instance, and see exactly where each of these items out of the code is actually logged on that report for you to be able to make sure that you have that information and that inspection checklist, which can really serve as a great tool, especially if this is not something that you've typically done previously and are super familiar with. So now we're going to jump over to our ERI report. We already touched on this a little bit, and because we had that overlap on the 2009 code thing, and that conversation there, where that comes from. And so here we have an ERI projected report where we're going to look at basically some numbers to tell us how good of a house this is, basically. And so again, we want that identified on our plan set to say, okay, with our proposal, our ERI is going to be our compliance pathway, and that tells you, great, I'm owed a report. I need to know what that report's going to have. Now, here's that information that I was talking about, and I'm sorry that I went on a little tangent there, but I think it's important to parse out the differences between these two and why. So your ERI here is looking at this energy rating index number based on your climate zone. And like I said, it's in the 50s. And as you move forward in the code into on-site power production, that number even drops more precipitously. And this is all representing percentage points that are improvements beyond the original, percentage point improvements beyond the original 2009 design. So here we're looking at that same sort of setup that we've had previously, where we have the individual requirements parsed out into a table, rather than the interspersed mandatory requirements that you've had in previous generations, like the 18 code. So that was a major shift between these two in the way that this lays out and the way that the readability works. So you're going to see this and effectively treat it like your checklist. In addition to the requirements of R406, we are going to jump over here and start to work through this as a checklist to make sure we have all the information that we need. So on our mandatory requirements here, again, that would be our 18 version. We'd be looking at this right here, where we'd see the same reference to our solar heat gain coefficients. The building thermal envelope cannot be less than the 2009 code, etc. When we jump over to the later versions of the code, obviously we have kind of a different setup there. So here is that ERI difference compared as we look at sort of those components. So here we have the 2021 on the left. We can see those numbers reduced. In the 2018, we can see they were 57s, 62s, 61s, 58. And then in the 2015 code, they were right around here in these mid 50s, give or take. So now we have some new standards out there, ANSI ResNet 301. This is an important one here for basically establishing the rating system. So as it moved from HERS to what we have now with ERI, ResNet ICC 301 now becomes the energy rating standard that's used in order to determine compliance with the ERI compliance method. And here we get a requirement out of the IECC that we're not going to include here any reduction in energy use of the rated design associated with any on-site renewable energy shall not exceed 5% of the total energy use. And that was an important component that was added later on in versions of the code because the concern has been, okay, we don't want a circumstance where we're able to build a pretty leaky, pretty uninsulated house and do a solar farm in the back and say that it's effectively net zero. We could build a better home and set a better standard to that. And so by focusing on putting a limitation on that, we're able to make sure that the offset that you get is good, but we're not just discounting all of the work that's being done for the house itself. And so as we look at this, right, like I said, we're looking at 100 on that thermometer being that sort of 2009 designed home. And then as we work forward here, if this is 50, right, that means it's using half as much energy, right? It's 50% more energy efficient, right? If this is 60, that means it's 40% more energy efficient, right? The higher the number, the more akin to a 2009 home it is. And so remember, this is really reliant, as we talked about earlier, we have the HERS rater system or the HERS rater discussion, which really kind of tells the story of this, that this is really contingent on third parties, right? Third party inspection agencies, approved agencies, to help assist with the process of making sure that this house is as energy efficient as it's intended to be. So this is sort of the rater third-party inspector method for being able to do that through the ERI compliance method. And so as we get into this, right, we can see here on our reports, we see ERI with PV identified as 61, ERI without PV as 61 as well, meaning that there is no PV or the PV is not being contributory towards the ERI outcome for this house. I would say that's probably not there because we're not seeing it there. In fact, if you go up here, you can see photovoltaics, you can see $0, you can see zero installed, zero anything. So that's been zeroed out. So basically, we have a house that's solely its ERI number there without PV. Now, compliance tools need to be in compliance with ICC ResNet 301, and that includes the list of softwares that you see here, where they're going to demonstrate exactly what I was mentioning here, this little sort of like thermometer kind of expression of this. That you see very often on that HERS index chart or on a lot of these reports where they're happy to tell you, hey, as this number goes down, we are improving from that baseline design by percentage points each time. And so your house scores a, say, 51 here on this particular chart. Um, as that's kind of gone on, it is important to note that like the HERS score and the ICC ResNet process, the reason that the standard was developed is because those started to diverge from each other. And so in order to have standardized process for the determination of that score, it is important to know which one you're talking about, whether it's HERS or whether it's ICC 301, as that transitions kind of happen as you work through different kind of versions of the code. Because Colorado is the same, similar to Texas in that we have home rule and we're allowed to adopt multiple different versions of the code based on whichever jurisdiction you're in. And so it is one of those things to keep in mind, especially if you're working multiple territories, exactly which standard you're using based on which edition of the code and which software, which thankfully a lot of these are smart enough to help you figure that out. But it's just one of those things you just want to keep in mind. So then otherwise, if we go to 105.2, this is sort of one of those things that, hey, no matter what your particular compliance method is going to be, you do have to provide this information, right? Your insulation materials, your fenestration U factors, solar heat gain coefficients, along with a number of other things here. You see your design criteria for your mechanical systems, your duct sealing, your air sealing details. Your air sealing details, in my mind, should almost live up here with numbers 2, 3, because it really is tied directly to the thermal envelope. It's kind of sitting down here at the bottom. But I'm glad that it was added in because it's an important component of making sure that we have those four basic pieces that we talked about an hour ago now, where we had that information kind of readily available for us. So yeah, no matter what type of building that you're providing, this always, or what type of compliance pathway you're using, you always have to also get this additional information so there's verification between the pathway, the report if necessary, any of these trade-offs, and we can make sure that all of this coalesces when it really matters. So with that, any questions? Okay. Well, I will wrap up with just a couple of little administrative things here. You've got some great webinars coming up in the near future, interior lighting design, and then the 29th, we will be doing our typical bring your questions when we have an extra Thursday in the month. We definitely do one where we get the whole team together and it's a nice panel discussion where you can ask anybody, hey, what do you think about X, or what would you do about Y, or how do you handle this? So hopefully that's an enjoyable experience. Hope you're able to make it. Hope you're able to join. And then in the month of June, you have three separate webinars coming up, 5th, 12th, and 19th, where there's significant time spent on your plumbing and your electrical provisions out of the energy codes here. So with that, please fill out the survey that we have. It only takes a couple of minutes, and it's super important to us to just make sure that we're giving people what they need, they're hearing what we need, or if there's things that you'd like to hear differently about, or any issues that you have, we really do want to hear them. We really do take that seriously. And please take advantage of the resources that we have posted for you. There's a number of great articles and documents that we have up that can really help facilitate this conversation, whether it be on your compliance pathways or other items that you're running into out in the field. And if you want to email us or reach out through our helpline, feel free to send that a quick shot there. And you can ask about any type of code. You can ask about anything you're running into, and you'll get one of the experts from the team to jump in and give you a hand. So with that, I will consider us all wrapped up. Let me do that. There we go. And yeah, if I'm not seeing any questions here, you can go ahead and have, looks like got about 2 minutes back, 3 minutes back in your day. Have a great rest of your day. I hope you thoroughly enjoyed, and hopefully we'll see you again soon. Thank you so much.